Bernd is here, and he will talk about 3 common pitfalls in microservice integration, how to avoid them. So basically, without further ado, I want to give the stage to Bernd. If you want to please share your screen so I can blend it in the stream, then the floor is all yours.
Thank you so much, Brian. Sorry. Screen sharing should be on the way. There it goes.
Yes, I see your screen popping up. Just a second, and we'll see that your screen is up. I will remove myself from the screen, and the floor is all yours.
Thank you so much.
Right.
Yeah, welcome. I basically hope you have enough coffee. Depending on where you are, it might be pretty early or pretty late. For me, it's quite nice in the afternoon. Thank you for watching. I want to talk about 3 common pitfalls in microservice integration. And basically, one of the motivations for the talk, there are a lot of things going on at the moment, but I actually like this slide a lot, this architecture graph, which InfoQ does once in a while, about what's currently going on the hype cycle. And if you look at it, you can see that microservices is late majority, which basically means that most people start to do microservices nowadays. It's not any fancy early adopter stuff anymore. It's really adopted on a broad scale. That's on the one hand, which basically fits very much my experience with what we see at customers. On the other hand, correctly built distributed systems is early adopters. So for me, that basically means everybody's doing microservices, but the microservices are inherently a distributed system. So seems we're not really good at that. And this is something we definitely have to change. And that's one of the motivations for the talk. There are a couple of more probably. And if you look at that, and I don't want to define microservices in detail, I don't have the time here today, but if you look at that, you will have basically a bunch of services which communicate with each other. And the more of these services you have, the different you have to view at the system as a whole. So one very important thing, and that's really a mind shift, is that if you have a relatively large system, some parts of it will always be broken. It might be the network to the component. It might be the component itself. You have a downtime or whatever. Something is always like not going very well. And one thing we start to accept is that this can happen, and then we have to deal with it. The important thing is not to avoid that, but to avoid that this really brings down like the whole system by doing some cascading failures or whatever. So this is kind of the picture we definitely need to avoid, which is very different to how we thought about developing systems like 5 or 10 years back. So this is kind of what we should have in the back of our minds when talking about that. Looking at a concrete example, I'm an example or a story person, if you like. You probably remember back in the days when we used to use airplanes, probably. And I like this example actually very much because normally you know it from the user perspective. If you want to fly somewhere, you book a ticket, and then normally like 24 hours before the flight, you normally get an email invitation to check in. For me, that was the case for this flight to London, actually. So that was roughly three years back, I think, a flight from Germany, from Stuttgart to London. And I could check in. That did work. But then when I wanted to send the boarding pass to me, that didn't work. I basically got an error message. It's a German website here, but it's very easy. It basically said, hey, we couldn't send you the boarding pass. There was an error, which that's what I meant early on. That can happen. And what I envision it to be in the background actually is like, okay, I was in front of the website. The website somehow called another service, like a microservice, for example, to check me in. The check-in microservice probably called a couple of other services in order to do its work. For example, let's say a barcode generator to generate that nice little 3D barcode you have on a boarding pass, right? So that's very easy to imagine. We don't have Eurowings as a customer. We have other customers doing very similar things. And so that's, from that perspective, that's quite a common picture. What I assume that happened in that case is that, for example, the barcode generation didn't work because the check-in was working. I could check in. So it was not the check-in service as a whole, but some component in order to generate the document didn't work. Okay. As said earlier on, that can happen. It can always happen. You can't avoid that. I don't have problems with that. They had some mechanisms in place to that this didn't yet bring down the whole system. A very important pattern in that regard is called the circuit breaker. Normally, I ask in the audience, like, who knows the circuit breaker? I can, experience-wise, 60, 70% of the people know that pattern by now. That's a very important basic pattern. It works like in your house. If there's something weird with the electricity, you don't wait for the house to burn down. You basically switch off the electricity. And that's the same thing here. So whenever something is weird, it basically switches off all communication to the barcode generator, meaning you get what's very often referred to as fail fast. That means you get an exception right away instead of getting stuck by calling other services. They did have that, so that was not the problem. I don't want to focus on that today. It's not for all the like airlines all the time like this. So it got a weird hobby actually for me. So over time, when I started to give talks like this, I started to collect error messages from airlines, which has a nice side effect that whenever something goes wrong, I'm kind of having a small happy moment, like, oh, I get a new screenshot. And this is from United Airlines, and they definitely didn't have something like this in place. So whenever I clicked on that, I get an 500, which is really the worst case. So failing fast, having some kind of circuit breaking is super important, but it's not enough. And that's where I normally see projects stopping. So they if they do REST communication, they know, okay, we should have a circuit breaker, service meshes, whatever, but that's it. And for me, the interesting part starts here. So let's look at that failure again. So let's see, let's say the barcode generator doesn't work, or the network towards the barcode generator doesn't work. If I have a problem here, the bad part of the design we saw in the example earlier on is that this error gets directly basically transported to me. I, as a user, see that in the front end. Hey, we can't do anything for you. And that's a pretty bad design, because what can I do about this communication problem down there? Nothing, basically. What's the strategy I normally do in this situation? I retry, right? That's what we do. We hit F5. We try it again. In this specific case, it didn't work. So I tried it again, didn't work, tried it again 5 minutes later, it didn't work. So the next thing I did is I created a calendar entry in my personal Outlook to remind me in the evening, like hours later. And then otherwise I forget these kind of things. And then I got the reminder from my calendar, I tried it again, I got my boarding pass. So that did work. It's what I call a stateful retry. But the bad design here is that why does the user, in this case, even the customer, the end user, has to do that retry? That's pretty bad. I mean, it's a boarding pass. I don't need that right away in front of my computer. I need it whenever I go to the airport in order to check in, not early on. Interesting enough, it was truly the same trip. When I went onwards from London, I had an EasyJet flight, and I had the same problem. I got the same error message, more or less. But EasyJet is more interesting. They give you the work instruction. They said, okay, we're sorry. We're having some technical difficulties at the moment. Please log on again. Okay, retry. If that doesn't work, please try again in 5 minutes. Increase the interval. And I like that best. We do actively monitor our site. We'll be working to resolve the issue. There's no need to call. That's basically like, hey, it's your problem. Like, sort it out yourself. And that's like a weird way of dealing with these kind of problems. It should be really much more like, hey, we have a technical glitch. Yes, sorry, right? But it can happen. It can happen. We will make sure that we sort it out, and then we send you the boarding pass whenever we have done that. That would be a much better like design of the whole communication going on. And in this case, it's very, very obvious, right? Because it's end user facing. But we see that kind of thinking very often if we have service-to-service communication. It's like, hey, I have a problem downstream. I just raise an exception, and now it's a problem of my client. And that's a really bad design. It should be much more like, hey, the check-in service should sort it out, right? If the barcode generator is not available, I retry it there, probably statefully, because it doesn't work right away. I need to do it in 5 minutes, in an hour, or whatever. So that's the much better design. And the end user, basically, I could tell him like, hey, I sent you the boarding pass in time. Don't worry, right? Okay. The problem, whenever I'm at that stage, whenever I discuss that with people, with developers, for example, it's like, yeah, we got that, but then we have state, right? And we're not really, nobody likes states nowadays, right? We want to be serverless, we want to be stateless. So state is kind of a really an ugly citizen here. We can handle state. So one option, what you can obviously do is you can write it to a database table, to a document database, NoSQL, whatever have you, right? You just store it there. But most projects sense that this is not it. If I store something, let's say in a table where I say, hey, I need to send this boarding pass, I need additional things like a scheduler regularly checking for boarding passes to send. I need some operations which looks at the table if something is stuck. If there's a problem while sending the boarding pass, I need to notify somebody. I don't have a client where I can send an exception to. So there is some complexity involved, which is totally true. There's another class of tools you could leverage, and that's where I come from, which are workflow engines. Whenever I propose workflow engines for that, very often the reaction is also really foreseeable. It's like, a workflow engine, really? These are these kind of BPM systems, like the huge monolithic, proprietary big vendor thingies, which are really developers typically hate. Is that what you're proposing? Yes, I do, because the market really changed over the last years. So it's not anymore that we have these kind of huge systems. Of course, I'm opinionated, like every human being, basically. I want to make it transparent here, that you can touch who I am and what's my way of thinking. My name is Bernd Ruecker. I'm co-founder and technologist within Camunda. We're an open source vendor. And we're doing an open source workflow automation platform, which includes a workflow engine. So I'm obviously a bit biased, but I worked with or on different basically open source workflow engines over the last 10 to 15 years with hundreds of clients. So I'm kind of got into that topic. I'm quite hooked up with workflow engines, workflow automation, state machines, and these kind of things. So that's my background, right? I'm quite enthusiastic about that, but it also means that I look onto a lot of problems through the lens of workflow engines. That's probably good to know. But if you're looking at the market, you see that there's a lot of movement, like Silicon Valley, they're starting doing bespoke workflow engines. If you look at the cloud market, they all do workflow engines, might it be AWS or the others as well. In the Java ecosystems, there are a couple of open source engines like Camunda or Activity, JBoss, JBPM, and some others. So there's really a lot going on. It's not like the big vendors BPMS anymore, like it was probably 5 years ago. I want to do a quick live demo to give you an impression how that works, what I mean by state or workflow engine for this kind of problem I sketched early on. By coincidence, I use the one from us, which is by coincidence also in the middle of the slide. I'm sorry for that. But you're totally free to use a couple of the others as well. Play around with it. It's more like I want to make the concept tangible. That's why I want to use code, right? So if you have such a workflow engine, and I show you that in a minute in a demo, so you get a better impression. What it can do is within your microservice, you can leverage the workflow engine, which is basically a persistent state machine, a durable state machine, in order to do things for you. Like, for example, say, hey, first thing you should do is generate a barcode. That might be a simple REST call, but if the peer is not available for whatever reason, what it can do is you can do the stateful retry here. And if you wait here, what the workflow engine does, it keeps the state persistent. So whenever, even if you crash, it's still in some kind of data store, depends a bit on the workflow engine you use, and you can set up from here anytime. You can do what I call stateful retrying here directly. So you could say like, retry it for the next, whatever, 10 hours or 10 days or whatever your use case is. So you have all the scheduling, all the operations, everything built in, right? So that's actually pretty handy for that use case as well. Let's do some code. Let's give you a better impression of what I'm trying to talk about here. I use a very simple payment service here in order to showcase that. So what you will see in a minute is I have a Spring Boot application doing payments. It provides a REST API. So I can basically just call that. And that uses like a credit card service for credit card payments also via REST API. Relatively simple setup, right? Everything I show here is on GitHub. So there you can see it. I can put it on Slack later on, so you don't have to like get it from your monitor now. Okay, this is the example, and let's go there. So what I have here is the example, and yes, this is Eclipse. You guessed right. So that's the example. What I have here is I called it Stripe Fake. So that's my credit card handling service, because I obviously don't want to do credit card handling for real here. So that's also a simple Spring Boot service, which is just providing a very simple REST API. And then I have my payment service running here, right? Also a Spring Boot app. And what I can do here, if I have a REST API, I can basically call it, right? So I have my payment, so I get the payment, my put request. You see that I will do a charge on the credit card. So far, so boring, right? Let's go for V2 for a moment. I explain you the difference in a second. Same thing, right? So pretty boring. And what I can do is I can simulate that the credit card handling is now behaving slow, right? So it will have a random delay. Whenever I hit that send button, it goes here to the payment service. That one calls the REST service over here, and that one will take, in this case, 33 seconds, right? This is a typical problem you have. So if the network, for example, is kind of flaky, you have a very, very slow connection, this will take long to respond. What you can see is like, I get an exception here. Why is that? That's a big difference between V1 and V2. So in V2, I used the circuit breaker, what I explained earlier on. Okay, 3 seconds, it's not so long, but now 31 seconds. So if I use the circuit breaker, what that does, it basically says, okay, there's a configured timeout, which I wait for the service to come back. It doesn't come back within that time, so I send the exception right away. That's fail fast, right? And that's very important, because otherwise, as you can see, this thread takes a while, this thread is blocked, this thread is blocked. So basically you get to the fire picture. So that's much better in V2. But still, that's now like, hey, we can't send you the boarding pass. Something is not working. So what I can do instead is I can go to V3, and let's quickly look at the code. So what I have, and I jump directly into V2, it's very simple. I have a REST API to retrieve the payment. I'm just using Spring Boot here, so nothing very fancy. What I do is I charge the credit card here. If I go into that method, what you can see is, okay, I use Hystrix. I know that's kind of end of life, but it's still in here. Use Resilience for J or something you fancy as a circuit breaker. And then what I basically do is I use a REST template to post to the credit card service, send over a request, get back a response, and that's it. Okay, not very complicated code. In order to add a simple workflow to that, what you can do is, in this case, that's what I meant earlier on. I use Camunda, it's open source, Apache license, and what you get there as well as a Spring Boot starter, so I can just hook it into my Maven POM, auto via the process engine or the workflow engine. I can, if I like to, I can create a workflow definition in Java code. So what I say basically, hey, I wanna have a workflow. It starts here, it ends here, and the only thing I do is what's called a service task, like one step in the workflow in order to call the credit card. And you can then hook up code to that one step. As I'm in Spring Boot, the easiest way, not the only way, but the easiest way here to use basically a Spring Bean, which is just defined here. So no programming best practices, right? So just have everything in one class in order to show it easily. So this is calling this one. The code within that, within the Spring Bean, is more or less exactly what you saw in the early example. So I just moved it into an own Spring Bean in order to hook it onto the workflow. And then what you have is you have a workflow engine. So you can do things like, hey, if it fails, I want to do retries with a time cycle of like do it 3 times with a delay of period time 1 minute. This is how you can read that. It's kind of an easy ISO format, right? And then you deploy the workflow, and whenever you charge the credit card, instead of doing it right away, you just start the workflow. And the workflow then does it for you, and that can do like all the retries, right? So far, so easy. So let's look at how this is working. So let's go to V3. This is still slow, 9 seconds. 9 seconds is too long for Hystrix. So what you can see is you get the exceptions. We should probably follow the log. Let's do it again. Yeah, so you saw the exceptions. It's too long, takes 9 seconds. You will even see the retries in the background if I keep talking for long enough. What you can also see is like 2 things. So one thing, where is my browser? Oh, hang on, it's on the wrong screen. There we go. That these kind of tools also have a UI where you can see what's currently going on. And very often, this is helpful for people in order to understand what a workflow engine is, because now you're basically looking at the data in the workflow engine, and there it's called cockpit in order to see what's going on and to look at the time actually. So so for example, I can see, okay, for payment B3, there are currently 2 waiting there. They're still in the retrying mode, and at some point in time, they will give up. 3 minutes. I haven't yet talked for 3 minutes, and then you get like even like a red bubble here saying, hey, there's a problem. You have to take care about that in some operations manner. Okay, so there are a couple of these kind of things. As the consumer now, you get back at 202. So that's different here. Before that we got either 200 synchronous, okay, or 500 synchronous doesn't work, and now we get back we got your request, we send you back something later on, right? There are a couple of strategies how to send it back. You can scroll through a couple of more versions which behave differently, which is quite interesting. So for example, V4 can do things like, hey, if something is weird, I go to asynchronous. If everything is normal, I basically even get a synchronous response. So there are a couple of things you can do. You can walk through the code yourself. So the idea here was just to give you an impression what I mean by workflow engine and how easy that is in order to use it within your service, right? So I have the payment service and I can define such a workflow. And right, and this is how I did it, like Spring Boot, and yeah, so far so good. I'm using BPMN here, so the workflow you saw, I defined it in code because I find that people sometimes, if they're not used to workflow languages, they find it easier to understand what's going on. Nothing hidden in the graphical format, but we auto-generate a graphical model because you saw that. You can obviously also model graphically. And then you have like all the operations and so on and so forth, and a lot of stuff. The important thing here to recognize is if you do that retrying stuff, of course, and you will not get around retries in distributed systems, you have to make sure that all the services you implement are idempotent. What does that mean? If you charge the credit card, you have to make sure you define some kind of like transaction ID, for example, which you send over in order to notice duplicate requests. Okay. If you have that infrastructure, and give me 2 more minutes, and then we are jumping in the Q&A. Sorry for that. You can leverage the same infrastructure. So let's assume you're sending messages back and forth. The same thing as you probably need to wait for things, you monitor timeouts, you escalate. This is where a workflow engine can help you a lot, because you can wait for a response message and escalate. I'm starting to get kicked out, right? And let me one last thing, and that's the last minute I need. Consistency or distributed transactions. That's normally the third pitfall. So if you have like a workflow or something you want to do spanning multiple microservices, you can't do a distributed transaction. It just doesn't work, right? So your business transaction might spawn multiple technical transactions. And there's a really good paper, you can read it later on, which explains why there's no technical transaction manager you can leverage there. So this is also where you can leverage these kind of workflows in order to say, hey, I do this. If that did work, I do this. If this then doesn't work, I can like undo the other activity. And that's also known as the Saga pattern in the microservices world. So there are a couple of these like use cases for that. And that's basically all I have. So you have to think about timeouts, retrying, compensation. And whenever you provide a service, you have to offer these kind of undo methods and think about idempotency. Thank you.
All right, thank you, Bernd. I got a couple of questions, so that's why I jumped in, because first question was, what do you think about handling this by the infrastructure? Can this, like the circuit breaker, can this be handled by the infrastructure? And wouldn't that be an easier solution?
I think for some problems you can handle that with infrastructure. So circuit breaking, yes. So circuit breaking, I think that's what we see in service meshes, that this is somehow delegated to the infrastructure. But if you're having more problems around, let's say, for example, stateful retrying, if we use that example, then you have to think about, hey, for how long do I want to retry? Does it make sense to do the stateful retrying? In this case, I want to send the boarding pass later on. What's the channel to reach the person there? All these kind of things can't be like guessed by the infrastructure. So this is on the, let's say, always on the business level. And so you have to mix and match. So you have some things on the infrastructure like circuit breaking, and then you have more complex patterns like, and this should be in the business logic. I think there's not an easy way around that.
I agree. There was a remark from Jeff Griggs in the Slack channel, like microservice integrations. Why not do messaging? So what's your remark on that? I mean,
okay,
it's probably another solution to it, but I want to hear your view on it.
Okay. So my personal view is that messaging makes a lot of sense in most situations. So that's why I have this example. It doesn't solve core problems, what I talked about here. So for example, if you send the command to some other service and say, hey, I want to receive the 3D barcode, and you never get a response, you still have to monitor that. You still don't want the person in front of the computer to see, hey, I don't get anything back. So you still have to solve that problem. Despite that, I think messaging is very often the better choice, but I see a lot of companies, or let's say development teams, struggling with messaging a lot. The complexity is simply higher, so I still see most people out there doing a lot of REST. So it's not that I find it better, it's just what I observe.
Fair enough. All right, Bernd, I want to thank you for your talk. It was, very insightful for me personally. So Thank you.
Thank you.
If you are able, please also publish your slides, because people are asking for it, and I think it's a good
Definitely.
way to educate people. So
And I
thank
will
you, Bernd.
hang around in Slack a bit if there are questions.
If you have questions, Bernd will be in the Slack channel. So thank you, Bernd. I will just remove you from the screen.